A right cylinder is shown. You need to find the volume. So the volume is going to be the area of the base times how tall it is. So it depends on how big the base is and depends on how tall it is. So the base is a circle. So the area of a circle is pi times r squared. And then depending on the height. So our r, the radius, since the diameter is going to be 8, the radius is 4, and the height is unknown. But since we have some triangle action going on, we can use some trig and figure it out. So here's the trig. You got a 90-degree triangle, and you know the base and you know the hypotenuse. The base is 8. The hypotenuse is 16. I guess you don't even need Pythagorean theorem or trig. You could just use Pythagorean theorem. So you could just do 8 squared plus x squared equals c squared. I guess the c is 16, so we're going to put a 16 here. 16 squared. So Pythagorean theorem, we got it all set up. Let's find how tall it is. So let's start simplifying. So we got 64 plus x squared equals 256. So minus the 64 on the left and the right, and we should have x squared is 256 minus 64, 192. Okay, now we've got to undo the square. So let's solve for x. Let's get x by itself. Ditch the square. Square root. Square root. And if you type that in your calculator, square root 192. It's a decimal. It's not a perfect square. So 192 is quite large, and we suspect that it's full of squares. So let's start pulling squares out of it. If you start dividing 192 divided by 4 and 48, 4, that right there is a perfect square. Square root of 4 is 2, so we already know 2 is coming out. Okay, let's bust up 48. 48 is 6 and 8. 6 is 2, done. 3, done. 8 is 2, 2, 2. So I already got a 2 on the outside, and on the inside I've got 1, 2, 3, 4, 2, 2, 2, 2, 3. So that is a square, that's a square, 2 squared, 2 squared, 3. So that square root is going to undo that square, it's going to undo that square, so another 2 is out, another 2 is out. So I've got 2, 2, 2 out. On the inside is 3. So you times all those 2's together. So this is 8 square roots of 3. So if we're going to do pi r squared times the height, and the height is 8 square roots of 3, we're going to do pi times 16 times 8 square roots of 3. And you're going to times the 18 and the 6 together. And here's what we're going to go with. C. So you have pi times 128 square roots of 3, and they just rearranged it. They put the pi over here, so times pi. Xavier cannot walk from point A to point B because there's a pond in the way. So if we go A, B, some pond in the way. So instead of walking straight from A to B, he is going to walk at an angle of 30 degrees from the path. So he's going to open up 30 degrees, and he's going to start walking around the pond. Then he's going to make a 90 turn and head B that way. So there's your 90. and finally walks 40 feet to his destination. So there's, after he makes the turn, the distance from the turn to B is 40. So your triangle needs to look something like this. Okay, 30 is a super nice hint. If it's a 30, this is a 60, and we know a 30, 60, 90 is half of an equilateral. So the other half is over the 30 and the 90. So the whole triangle looks like that. So if that's 40, that's 40, that's 80, that's 80, and the center, this middle, is going to be 40 times the square root of, man, I cannot write threes. 40 squared is a 3. So the question is, if he were able to take a straight path, how far would he walk? So straight from A to B, he would walk 80. If ABC is a right triangle and C is your 90, so there's a 90 right there. Use these relationships to create two true statements. So kind of drag and drop. Okay. So let's drop this. Cosine of A. Now check this out. If I do cosine from A, that means I'm going from A. That means this one is the hypotenuse. This one is the opposite, and this one is the adjacent. So the cosine of A is going to be adjacent over hypotenuse. Okay, now if I copy and paste that exact same triangle, so we call this ABC, and if I don't go from A, if I go from B, this one is still the hypotenuse. And now this one is the opposite, and this one is the adjacent. So let's say I use a Pythagorean triple. Let's say I use a 3, 4, 5. Let's say I make that piece 3, that piece 4, and that piece 5. So this piece 3, this piece 4, and this piece 5. So the cosine from A would actually be adjacent to hypotenuse. It would be 3/5. And now to get 3/5, if I'm not going from A, if I am going from B, that same fraction, 3/5 would be using the opposite and hypotenuse. So the same pieces, but now the opposite and hypotenuse is a different trig. That is the sine from B. So the cosine of A is going to give you the exact same fraction as if you do the sine from B. And we could say the cosine from B is going to give you the exact same as the sine from A. So those are the relationships that are true. Don't ever go from the 90. Don't ever go from C. This one and this one, these are trick questions. Don't ever place your marker from the 90, because the opposite of the 90's got to be our hypotenuse. And if we put our marker on the 90, that's the hypotenuse, but it would also be the opposite. And then both of these pieces would be adjacent. We wouldn't know which one to call adjacent. So if you go from the 90, that's a trick question. Okay, this one, the figure shown, sine of phi, so this is another Greek alphabet letter, is 3/5. So they want you to look right here. So from this angle, sine is the 3 would be the opposite, and 5 would be the hypotenuse, but there's kind of no triangle. So you kind of have to make one. So the opposite, this one is opposite. So this one is the 3, which means this is 3, which means this is 3. So some kind of a rectangle. And the hypotenuse would be this piece. So this piece right here is 5. So now, if that is true, what is the cosine from theta? So the cosine, now you're going from here. So cosine, that's opposite. That's adjacent. And the 5 is the hypotenuse also. And it would be the same. It's going to be 3/5. Number 11. The extension ladder on top of a 6-foot high hook and ladder truck is 150 foot long. The angle of elevation of the ladder is 70 degrees to what height on a building? Alright, so you got some building. Then you got a fire truck that has a ladder. So now the ladder is going to extend and reach the building. The ladder, the extension ladder is 150 long, so this is 150. And it is on top of a 6-foot truck, so the distance from here to the ground is 6 feet. Okay, so there's my triangle. The angle of elevation, so going straight across, going up, this is 70 degrees. So the question is, what height on the building can it reach? So from the ground, what is this mark right here? So from here all the way to the ground, that's what we want. So I know this is 6 foot, so the triangle I'm going to use, I'm going to find this piece right here. And then at the end I'm just going to add the 6 feet height of the truck. So we're going to mark it from the 70. If we mark it from the 70, this piece becomes opposite and this piece becomes hypotenuse, and the trig that marries those two together is sine. So you're going to do the sine from that 70 degrees, and the ratio should be x over 150. So now the trig's done. Now it's just algebra. Solve for x. So undo divide 150. So I'm going to times by 150. I'm going to times this by 150. So 150 times the sine of 70 and that equals 140.95. So this is about 140.95, and if I add the 6 to it from the ground to the top of the building, it will reach 146.95 feet. A right triangle has side lengths AB and hypotenuse C. So C is your 90. So C is the hypotenuse, A would be this side, B would be this side. For the angle theta between the hypotenuse and side length A, so here's the hypotenuse, so theta is going to be right there, because here's side A and there's the hypotenuse. The sine is 3/16, so the sine of theta is 3/16 sine of theta. So this piece is 3 because it's opposite, and this piece is 16. Okay, another right triangle has side lengths 2 times A, 2 times B, and 2 times C. So they took that original triangle and they just doubled it. So if we call that A, C, B, they're going to double everything. So this is going to double to give you a 6, this is going to double to give you a 32, and this is going to double to give you a 2A, whatever A is. So theta is in the same spot. So they're using phi instead of theta, so it's a different letter of the alphabet, but it's the same idea. It's going to mark the same angle. So if you put it in between the hypotenuse and A, so yeah, it's in the same spot, the hypotenuse and A, right here. which is where we put that one. Well, let's see, what does it want? What is, oh, sine. It wants the sine. So the sine is, from that angle, is going to be opposite over hypotenuse, so it's going to be 6 over 32, which is the same exact thing as 3/16. So if you change the size of the triangle, it doesn't matter, because at the end of the day you're going to simplify the fraction. It will always simplify down to what you started out with. Get some more elevation and depression. Statue of Liberty stands on a 150-foot pedestal. From a point 280 feet from the base of the pedestal, the angle of elevation to the top of Liberty's torch is 47 degrees. So here's some pedestal, then here's the Statue of Liberty. Okay, so here's what we know. This base is 150. So from the top to the bottom of the base, that's 150 feet. From a point 280 feet from the base, so if you go from the base clear over to here, that distance is 280 feet. The angle of elevation to the top of the torch, so right here, to this point right here, to there, is 47. Find how tall the statue is. So I'm going to come all the way down to here. Dunk. And there is your triangle. Or you could come down to here and go over, and that will still be 47 degrees. And we could find this guy right here. Or you find the whole thing, but then you got to subtract 150, because that's including the pedestal. So if I want to do it without the pedestal, I'm just going to shrink this triangle down a little bit. So if I go from right here, this is still 280. So if I go from this angle, the x is going to be the opposite side, and the 280 is going to be the adjacent side. And the trig that uses these two together, opposite and adjacent, is going to be tangent. So I want the tangent from that 47 degree angle is opposite over adjacent to 80. So undo the division, times this by 280, times this side by 280. And this is what you're going to type in your calculator. 280 times tangent of 47. And that should be 300 feet tall. Pretty close to 300 feet. 300.26 feet tall. Number 14. A TV antenna stands on the edge of the top of a 52-foot story building. So you have a skyscraper. So from here to the very top to the bottom, 52 feet. That's how tall the building is. Then, what do we have? A TV antenna. Oh, this is kind of the same as 13. From a point 320 feet from the base of the building. So if I go over here, 320 feet. Dun, 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 dun. The angle of elevation to the top of the antenna. So we got some antenna. Whatever it looks like. So the angle of elevation to the very top of the antenna, so you find the highest point of the antenna, and angle of elevation is 64 degrees. And then each story is 12 feet high. Find the height of the antenna. Now, this just might be extra information. This might not even really tie into the problem. I don't know if we need to know each story is 12 feet. Because we know already the height of the building. The height of the building, oh no, 52 story. Alright, so we do need that. So it's not 52 feet. So we need to do 52 times 12, and that will give us the height. So that is actually going to be 624 feet, which is more like it, because 52 feet is not very tall. Okay, so you're building 624 feet. Now we are going to find, if we mark it from here, if we're going from the 64, this piece right here would be the opposite, and this piece would be the adjacent, and the trig that marries those together is tangent. So let's do tangent from the 64, and tangent from the 64, let's say we don't, let's not even worry about this 624 yet. So let's say we don't know that, but the adjacent we know is 320. So now we are going to times by 320. We are going to times this by 320. So 320 times the tangent of 64. So from the very, very, very top to the bottom is going to be, the total distance is 656. 0.1, I guess. And we're going to minus 624 of that, because that's how much the building takes up. So if you minus 624 from that, that antenna is going to be like 32.1 feet tall. That's how tall the antenna is. Last problem's kind of review of all the parabola stuff, the quadratic. Which one has a greater max? This one by far is the easiest, so the max is the highest point of the parabola. So you need to know kind of where the vertex is. And this parabola would have a max. If it was oriented like this, this parabola would have a min. That's the lowest point on the parabola. So your max right here, the highest level looks like the max is 5. Okay, now B, they give to you in y equals ax squared plus bx plus c. And C, they give to you in y equals ax minus h squared plus k. So this one's called vertex form, and this one's called standard form. Vertex form is pretty easy to find the vertex. The vertex happens at the h and the k. And the k is 25. And the h is after the minus. So this is really x minus a minus 4. So your h is minus 4. So that means if I'm going to plot this vertex, I'm going to go left 4 and up 25. So this vertex is a lot higher. This max is 25. So far this one is winning. Now B, if it's in standard form, to kind of find your vertex, it's a little more work. So you could either complete the square and change it to vertex form, or you could use part of the Pythagorean theorem or the quadratic formula, negative x equals negative b all over 2a, and that will give you half of your vertex. If we do negative b all over 2a, so a equals negative 2, b equals 24, c equals 3. So if we do a negative 24 all over 2 times a, so I guess that is the a, 2 times a, So it's negative 24 divided by negative 4. So that is x equals 6. And here's what that means. If you come over here at 6, there is your line of symmetry. So your parabola is going to fold over this line. So the vertex is going to happen on this line. Your vertex is some x and some y, but you just found the x. It's just kind of the same as h and k. So your h we just found is 6. So I'm going to go over 6. Now the only way to find the y is to take 6 and plug it in place of that x. Take 6, plug it in place of that x, and that will give you the y if you do the math. So y equals negative 2 times the 6 squared plus 24 times the 6 plus 3. And then if you just punch that in on your calculator and hit enter, it gives you a 75. So this means you're going to go over 6 and up 75, which is the winner. So this max was 75. This one was 25 and this one was 5. So B by far has the greatest max.